Okay, so my video assignment for this section is sketch the graph of g of x, absolute value x minus 5, closed absolute value minus 1, by identifying and demonstrating all transformations using a dashed curve and finding intercepts algebraically. So basically, to graph this, you're going to want to find out what the parent function is. And as you can see, the parent function is f of x equals the absolute value of x. And to graph the absolute value of x, it's just a V shape, and it starts at 0, 0. And if you don't exactly know what it looks like, we can put in a couple points. We'll put a -1, -2, -1, 0, 1, 2. So the absolute value of -2 is 2. The absolute value is -1 is 1, 0, 0, 1 is 1, 2 is 2. So -2, 2, 1, 2, up 2 is right there. -1, 1 is right here. And then it's 1, 1 over here, 2, 2 over here. And I'm just going to put this together with a dashed line because it's not exactly the function we are given. So okay, so now let's evaluate what we have. I want to start off with whatever is outside of the function because it's a little easier to handle first. So it says -1, so -1 means down 1. So I'm going to use a different color for this, and we'll move every point that we have down 1. So down 1, 1. Okay, and this is not quite the function yet, so we're going to use a dashed line again. Alright, so now the last thing to do is do the -5, which is inside the function. And a -5 on the inside of the function is actually the opposite of what you think. It doesn't go left 5, it goes right 5. And an easy little trick to figure that out is you have to find out what makes this equal to 0. And basically you have to add 5. So you add 5, which means you go right 5. Alright? So we have to take the blue one right 5. So 1, 2, 1, 2, 3, 4, 5. That one goes right 1, 2, 3, 4, 5. And then you can just fill in the rest. And this is our graph, so used a straight line all the way through the points. Alright. So now basically what we have to do from here, since we graphed it, is find all the intercepts, but we can find them graphically, but we can also find them algebraically, which is what the question is asking. So to find the intercepts, basically all you have to do is make both x and y equal to 0. To find the y-intercepts, you make x equal to 0, so we'll make x equal to 0. The absolute value of -5 is 5 minus 1, so it's 4. So the y-intercept is 0, 4. Okay, and then to find the x-intercepts, you just go put f of x or g of x equal to 0, which is y. So x minus 5 minus 1 equals 0. So to solve this, you add 1, you get x minus 5 equals 1. And to get rid of the absolute value, you put plus or minus on the opposite side, because it's the distance from 0, so it could be a positive or a negative. So positive 1, negative 1. So plus 5, x equals 6, plus 5, x equals 4. So the x-intercepts are 6, 0, 4, 0. So we can already graph this. They technically are already graphed. So as you can see, the intercepts up here, this is one of the x's, 4, 0, and this is 6, 0. And then the y-intercept did pass through that one, which is 0, 4. So to find the intercepts algebraically, it's kind of a quick check to make sure you did your transformations right. Or you can always do them first, but I find that a little confusing because then you still have to start out with your parent function to find your transformations. So that is all, I'm pretty sure. So thank you for watching. I hope you understand now. Okay, bye.